Hello, everyone. So thank you so much for joining this call for BIDS extension proposal for quantitative MRI. I should first start by telling you what is not quantitative MRI. Probably the contrast of these conventional MR images that we are used to seeing as structural images are created by adjusting the relative contributions of some fundamental MR parameters such as T1, T2, and proton density by using different types of sequences with different parameters. And doing these, we can also pull some different tricks such as apply an inversion pulse and, for example, null out the signal from CSF, which gives us the flare images. And these contrasts are being used in clinics about 40 years as a cornerstone diagnostic tool. But the reason we call them qualitative is that these images come in arbitrary units. So for example, when we take a look at this flare image, we can see that 3 MS lesions exist. And that's the only information that we can gather from this image. We cannot tell much about their progression, or we cannot make sure if these values would change if we go to another scanner, given that they are in arbitrary units. Whereas quantitative MRI aims at calculating the meaningful numbers per voxel and that come in physical units. And this is achieved by collecting multiple conventional like MRI images by systematically altering acquisition parameters between these constituent images of a group scan. And then we use a mathematical recipe to derive those numbers. And this recipe may contain some MRI signal representations or biophysical models, or a combination of both. And then fitting data to this recipe through various algorithms, we obtain quantitative maps, and they always come with this color bar telling us the range of values that is covered by these images. As we can have physical models that gives us the basic values such as T1, T2, proton density, and other contrast, we can also combine these values into biophysical models to get more useful information about the tissue microstructure, and we can get information about myelination, iron concentration, or even a number called G ratio, which is the ratio of the inner to the outer diameter of an axon. So yeah, with quantitative images, we have informative numbers with meaningful parameters that have a well-defined range of values, and they give us promising biomarkers by combining them. They give information about tissue microstructure. So if you remember this flare image, we said that there are 3 lesions. But if we look at the G ratio MRI of the same image, we only see one of these 3 lesions as visible. And the background of the many of the white matter voxels are here around 0.7, which is known to be the range for healthy subjects. But only one of these 3 lesions show the G ratio value of 0.3, which indicates impeded transmission of signal. So yeah, this is pretty much what quantitative MRI is trying to achieve by combining multiple images with biophysical modeling and MRI signal representations to derive numbers that are reproducible across time points and scanner sites. Thing is, we have an array of methods. There are so many different sequences, so many different models, many different algorithms to derive these numbers. They in a wide range. So, but we have much less standards. With Beto 1, we are trying our best to choose the portion that we believe is going to be used the most by OHBM community. And now I'll pass the floor on Gilles for the rest of the presentation and stop sharing my screen, I hope.
Yeah, maybe we can already get Chris and Alberto also on the stage. No, too many videos.
Yes.
This one? Okay. Do you see the slide?
Yes.
Okay.
Now I see the presentation.
Good. Yeah, so as Agah already introduced, qMRI is a way of getting, in a way, nicer images of the brain, where we have absolute units like T1 in seconds or T2 star in seconds, or even magnetic susceptibility using QSM in parts per million. And I got involved in the BIDS extension proposal 1 about 3 years ago, when I was working with MP2 range data. So I think that's one of the most used sequences that can already do qMRI. You can use it to make T1 maps that are informative of how much myelinization is going on somewhere. And I just emailed the BIDS mailing list because I had this data and I wanted to share it with other people. And because of that, it was very important that I put the parameters in a meaningful way next to the data, because this metadata of parameters is absolutely crucial, specifically for qMRI. Like Agah said, what you usually do is you sweep over a certain amount of parameters, for example, inversion time in the case of MP2 range, and then you fit a mathematical physical model to get to the original data generating physical parameters like T1 in seconds. But for that, it's crucial that you have these parameters. And what I figured out is that even for MP2 range, which you can actually find in many Siemens scanners under the standard protocols, it was unclear how to put all the relevant parameters in there, and therefore it would be, in a way, impossible to share this data in a nice way. So I asked a question on the BIDS mailing list, dudes, how and girls, how am I going to do this? And then something very interesting happened, I think, because we couldn't get out of it. We couldn't come up with an answer together in the mailing list. One of the interesting things is that some parameter names that are very common in functional MRI, something like repetition time, it turns out when you go to the field of qMRI and the MR physics get a bit more complex, and also the diversity of sequences becomes more complex, these concepts that we think know well turn out to have different meanings. So for example, in the MP2 range, there's actually 2 repetition times that you could arguably call repetition times, and were also called repetition time in the original paper. So there's the repetition time between the non-selective inversion pulses, and there's the repetition time between the readout lines in the gradient echo readout block. And basically, I think we came to the conclusion in the end that in the current BID standard, there's no way to encode this information, to clearly annotate the data. This is the TR of the gradient echo block, and this is the TR of the inversion pulse. And this took a lot of time. It took about 68 posts in the mailing list, and I think Chris Gorgolewski gave a nice summary. He called it the repetition time wars of 2017. And well, luckily at the end we got to some kind of truce, and the truce was the BIDS extension proposal 1. And it was originally a very long Google Drive document, and now we moved to GitHub, and we really made it a fork and now a pull request of the main BIDS specification. And I think it's very important to mention here that many people, literally dozens of people, have now contributed to this in any way, just by their knowledge of MR physics or by writing text and stuff like that. So it's not just the 4 of us that did the work here. What I would like to say is that it took a lot of time to do this. And if I can give a tip to people that will write new BIDS extension proposals, I think what's very, very helpful is if you don't focus too much on very philosophical debates about what is a repetition time and what should be part of BIDS and what's not. You should really, I think, focus on concrete use cases. MP2 range is a protocol that's being used more and more by actual neuroimagers that are interested in the brain. We need a way to share this data. MPM, so multi-parameter mapping, is another example of a protocol that's used a lot. Focus on that. Focus more on that than maybe every individual It doesn't have to be a complete philosophical, coherent whole, I think. It should be applicable. Anyway, after 3 years of hard work, we now got to a point where we did the actual pull request to the BIDS standard. So it's open for everyone to give some feedback on it and say, did you think about this? You could specify this better, or we think this goes too far. And we already saw some great feedback from many people. Some of them, I think, are also present today. So that's great. Thank you so much for that. Let's talk a little bit about what exactly entails the extension. Before we go to the examples, which Alberto and Chris will do, which I think will be most illustrative. But I think the main getaway is that basically we split up the original idea of the anatomical modality. So the original anatomical images that were in the examples in the BIDS standard were really conventional images. The classic photo camera, where you just have a certain gray intensity with a number that doesn't necessarily mean anything, whether it's 100 or 200. It's just the contrast of the whole image that is informative. So in addition to those weighted images, T1, T2 weighted, PD weighted, we now also have the quantitative maps. So the output of these qMRI models that really gets to these physical measurement, or these physical parameters underlying the signal, and grouped scans. And grouped scans, I think, is the most important one and the most difficult one, because those form a way of describing data that comes out of qMRI protocols. So data like MP2 rate, MPM, but also, for example, multi-echo gradient images, where you go from a short echo, where you're mostly PD weighted, to a long echo, where you're mostly T2 star weighted. But everything in between is somewhere in between. So it's neither T2 star, neither PD. And the reason that you do all these echoes is ultimately because you want to fit a model. You want to probably fit a exponential curve to it. So these group scans are really a way to say, as a dataset curator, look, we have these 5 images. They belong together. They belong to this class of protocols. And this is the way that you probably want to use them, right? So in MP2 rates, the first one is probably going to be T1 weighted, and the second one is probably going to be PD weighted. And you probably want to take the ratio of that, and then you can fit T1 maps, etc. So the most important additions is what I already alluded to. The first thing is that we now have 3 distinct classes: traditional weighted images, group scan collections, so the MP2 rates, the MPM, a set of images with different contrasts, of which we know very well what the acquisition parameters are, so that you can fit your qMRI models, and the output of the qMRI models, the T1 map, the T2 map, with the physical units that you can compare across subjects and scanners. We also needed to include some new key value pairs, like flip angle and inversion time. And also what we did is that we noticed that the BIDS standard is mostly very consistent. So usually it says T1 weighted, T2 weighted, but there were a few suffixes in there, specifically just these 3, that we would like to recommend against, because they're a bit ambiguous. Flash is actually a vendor-specific a term for basically a gradient echo. PD, it's unclear, is this a PD map or is it a PD weighted images? Is it a traditional scan or some kind of map? So we now split it up in PDW and PD map, and T2 star is the same. It's T2 star weighted or T2 star map. So we don't remove them from the spec so that they're not, we don't get backwards compatibility issues, but we do get them out there. We recommend against them so that we make sure that people can be less ambiguous in how they curate their data. And basically, because of these more complex anatomical images, we thought we need to get 2 brothers for repetition time preparation. So for example, the time between 2 inversion pulses, and repetition time excitation. So the different excitation pulses within a gradient echo readout block. And also we put a lot of work in adding examples and guidelines for 8 common structural multimodal quantitative MRI techniques. So MPM, MP2 range, but also multi-echo gradient echo, MP2 range, ME, variable flip angle. So actual protocols that are actually being used, we looked at them and thought out, okay, what is the best way to organize this data? And yeah, we included that into the BIDS standard with some examples and guidelines. And there's also an open science framework repo where you can find this data. And then I would like to give the floor to Alberto. And how do I go? This is pretty freaky. To a video. How do I do this? Help.
Are you sharing your screen, Gilles?
I think so. I don't want to.
Then I can just kick you off and then invite you back on. That was easy. Okay, I'll invite Alberto up. We do have place for one more, so I can invite either Christophe or I can invite Gilles back on. The screen share takes the space of one person. Okay.
Thank you, Steven. I'm going to try sharing my screen.
Yeah, no problem. Welcome.
Can people see the presentation?
I can see it.
Okay.
Is it full screen for everyone? Yep.
Okay, brilliant. So basically, so for this kind of second part of the talk, we wanted to tell you a little bit about the examples that we've been working with. And so these examples are essentially real-life data, which is either already available online or data that we've kind of contributed that we put in BIDS format. And there are kind of two big reasons for this. One of them, Gilles kind of pointed to already, which is that when kind of developing a proposal, actually, what we found useful over time is that it's easy to kind of get lost in the philosophical details of kind of what should change, what shouldn't change, what's part of BIDS, what's not. But actually having some concrete examples that you work with and that you update kind of as you go along and as you integrate changes that people suggest has been really, really helpful. And the other reason why we wanted to tell you guys about the examples is that they're actually a really, really great place to start getting familiar with BEPO1 and also with qMRI in general. So these are essentially data that you can go and download, and you can open on your laptop and kind of look at the data yourself. We have 8 data sets in total so far that we've put in BIDS format online. They are in this website here, so they're on OSF, and there's this link here that I can share on the chat later. And yeah, we have 8 data sets so far. I put the list here also because if you have any other data set that hasn't been included, just please feel free to get in touch with us and we can work with you to put it in BIDS format as well. And today we're going to focus on 2 specifically. So I'm going to start by talking about the MP2 Rage one to give kind of a simple example, and then Chris will go through a kind of more complex example of multi-parameter mapping. So this is kind of what the top-level directory looks like, and I think probably most people here are familiar with it, but essentially there is kind of a JSON for the whole data set and 2 kind of subfolders, one for the kind of raw data and one for the derivatives. If you open these folders, this is what it looks like kind of in our proposal. And this may look like quite a lot of data and a bit confusing, so I tried to highlight the different parts. So in the raw data folder, there are kind of the images that you get from the scanner. And these are kind of grouped into these grouped scans, as Gilles was mentioning before. And then they get processed into quantitative maps. And this is obviously because they're most often derived from kind of like an offline pipeline. They are kind of in the derivatives folder. And one interesting thing that I wanted to point out is that one thing that BIDS will allow us to do is to be really transparent about actually which pipelines do we use to calculate these qMRI values. And for example, here you can see that all the derivative data is within one folder that has the name of the kind of Python pipeline that has been used to derive the map. But potentially you could also have several different pipelines that kind of compute the quantitative values in different ways. And this is a really nice way to kind of be really transparent about the way that you calculate them. So this is just to give an introduction to the basic kind of folder structure. And now I'm going to pass the screen to Chris. Let's see if I can do this.
I can bring him on.
Thank you.
Yep, he's connecting.
Do you hear me?
Yeah.
Okay. How do I share things now?
You cannot. I will have to throw Agah off if that's okay.
Just get back to this one. Control
Now you can share.
Is it shared or I'm not hearing
There's
you
a
guys,
share screen.
Are you hearing me? Seeing me?
Yeah, I think we can
I'm not
you, but not the screen.
You're muted, Christophe. This happens. I think I will throw you off and call you back on again, and then it should work.
okay. You hear me now?
Yeah.
Yes.
Okay. And if I'm how do I share my screen? Share screen. So what the hell? Why? Sorry about that. That's the first time on. You see something?
Yes, we can see. There something is happening. Seems like stuff is loading.
Yeah, seems a bit. Okay. Let's try.
If it's it seems like Google Slides, so maybe someone else can try.
Yeah. So now it should be. Is it on now?
Yes.
Okay. So there is a bit of hiccup in this voice band routine. I'm sorry about that. So I'm here discussing the data coming from a multi-parametric mapping protocol. And these are data that have been made available by Martina Callaghan from London. And the data are just available. They've been published. So when you download the data, when you look at that, there is a paper as well about the data that you can check out so you get a full description. And this protocol is a bit more complicated than a standard MP2 RAGE. And here, pretty much we have 12 series of images, some with the standard contrasts in terms of PD-weighted, MT-weighted, or T1-weighted images, but you also have lots of maps that are measuring sensitivity of the antennas and emission receptions, the B0. So when you look at the whole data sets, you have those 12 series of images. When you unpack, that's exactly what you get. And for example, here, the T1 weighted images, you have a series of 8 T1 weighted images with the accompanying JSON. The JSON contains a dump of the DICOM header, so you have all the acquisition parameters, but you may not be interested in all those data. So that's just representing what we have. We have the PD weighted, MT weighted, and T1 weighted with different echo times. So we have slightly different contrasted images with different echo times. As well, and along that, because each series of images were acquired in a different series at a different time, of course, they also acquired position-specific receive field mapping for the antenna using the body antenna and the head coil. And with those two, you are supposed to be able to reconstruct the bias in intensity that has been introduced in your anatomical images. Along that, they also measured the transmit field, so that's so-called the B1+. They used that using spin echo, stimulated echo, so assessed sequence where they use 11 different flip angles, and you have the standard B0 map. Well, that's the default sequence on a Siemens scanner, where you have 2 images acquired at different echo times, and you have a difference in the phases of those 2 images. That's pretty much what you call a field map for the functional MRI. So all those images make up for something fairly complicated. You have more than you close to 50 images altogether with different width resolution, different acquisition parameters. And the idea is that you want to make sense of them using a bunch of equations. So you want to fit a model to the data, for example, to derive the different quantitative image values that you're interested in, R2 star, the R1, the magnetization transfer, proton density. And to do that, well, you need to have data acquired at different echos, and you want to be correcting for the different biases that could be introduced in your images, i.e. the B0, the B1 plus and B1 minus, so the emission and reception of each antenna. And so to help making sense of that fairly complicated data set, we have converted the data that are available, and I repeat, they just represent a bunch of images with the accompanying JSON, and we've converted them into a set of anatomical images, each of them with pre-specified keywords in the file name, so that we know this is the first echo, that would be the second echo, and so on. Here there is only one flip angle. The MT here is on, but over there it's off. And this is the grouping suffix to say, well, this is a MPM protocol. Importantly, the JSON file has been also trimmed down and is now in line with what you expect from BIDS in terms of manufacturers and sort of housekeeping of where the data come from. But also you have the key acquisition parameters in terms of repetition time excitation, echo time, flip angle, and so on. So here I only have one value for one echo, but if you go to the next echo, that number would be slightly bigger, and so on from one image to the next. Similarly, for all the B0 and B1 maps, you can group them together in the Fmap folder, where you define these RB1 would be the receiver B1, TB1 would be the transmission. Here it's using an API protocol, and effectively you're also providing the necessary acquisition parameters that are of importance to use those data, as well as here pointing to which anatomical images they pertain, and they are intended for here the MT on eco 1, 2, 3, 4, 5, and 6. So that's just to say that these images will be, well, of course, necessary to properly correct those images. With that put together, the idea is, of course, that you will generate these quantitative maps. So with the NPM, what the whole processing pipeline spits out in terms of map are the magnetization, transfer, saturation on the left, proton density, and then the effective transverse and longitudinal relaxation, R2 star and R1. So at each and every voxel now we can see that we have sort of a multi-channel information. So we have information about that piece of tissue in the brain in terms of longitudinal rate, R2, proton, and MT. And here, for example, that's fairly typical of the R2 map, where you see here a larger R2 value in the basal ganglia. And this is associated typically with aging because of iron deposits accumulating over time. And of course, because you have iron, then that means your T2 becomes smaller. And if your T2 becomes smaller, that means that your 1 over T2, your R2 becomes bigger. And you have those bright spots. So this is just to illustrate one of the tissue properties that you can visualize. And these, of course, can end in sort of a derivative part of the BIDS section. And you would have your 4 quantitative maps, with the MT set, TD map, R1 map, R2 star map. But you can also have the field maps for the reception and transmit maps plus the B0 maps because these now are really representing the effect of your antenna sensitivity. Oh yeah, and this is sort of the schematic of the toolbox that I'm working on to generate those quantitative maps from the data that are acquired to the quantitative maps. There are, of course, other tools existing. I'm just jumping on them. There's the qMRI I've just mentioned, but then there's qMRLab, PyM, P2Rage. So the key thing really with those qMRI data is that what you get from the scanner has to be processed in order to generate the images that will be used for your analysis later on. We think this is useful because it brings information about not only the morphology of the brain, but the tissue properties. So it has applications in, of course, anything that is linked to development, but anything that has longitudinal change or diseases has potentially some interest, or those techniques could be useful for those fields. And of course, what we're proposing is what came out of the brain of a dozen imagers, MR imagers, and we've tried to gather the information from as many people as possible in order to make the standard or the proposal flexible and accommodating, but at the same time keeping things organized in a meaningful way. So we encourage you to ask questions right now, or through the GitHub pull request, or in person if you want to just chat with us. Just come and talk to us. I've here just highlighted a couple of maybe wouldn't say controversial topics, but issues or points that may need further discussions, or I would rather say clarification in what we mean. And I'm thinking of top of my head, of suffixes. Where do we put quantitative maps and derivatives? What is a derivatives? That's a long discussion with BIDS in general. And in terms of field map sequences, also we've taken a shot at bringing them together in one place. But yeah, that's something that's probably worth discussing. Thank you.
Thanks, Chris. Should we go over to questions, or what do you want to do? How do you want to approach it next? Can you invite some people on screen, or?
Maybe we can tackle the questions. Probably get. I don't know how many people can be on screen, but
I can get one more person on screen.
Gilles, and if needs be, I'll just step down and leave the room for Agah.
Okay, so we can maybe start looking at the questions. I think people have already discussed that quite a lot. But the first one was:
yeah.
Is there a public available collection of qMRIs, raw and processed, done on phantoms?
So I think we can be 4 even, right?
Yeah, but I'm the 4th one.
Well, there were 2 questions anyway. Is there a publicly available collection of qMRIs done on phantoms? Well, apparently Agah already answered that question. He has that.
Do you want to put Agah in my place so you can answer directly?
I can do that.
Maybe. Yeah.
Cheers.
I'm also happy to step down.
Can we add him?
Agah is on his way. Okay, you're muted.
So Agah.
Yeah.
What about this publicly available qMRI?
Yeah, I already shared the link. That answer, it's the data that next year is in collection for Visible Research Study Group challenge of this year by ISMRM. There are multiple ISMRM system phantom images for the T1 spheres phantom, and those images were acquired with Emergent recovery T1 mapping method. So we also provided the steps to process that data. And we also have some of the participants provided for across time frames as well as across. Yeah, so the good data to explore across sites and across runs variability with T1 maps. I guess that's what Yaroslav was interested in. We had a little chat about it.
So Tibor had a question about the group scans concept, right? We group these images together that belong to the same qMRI protocol. Can we use that for other modalities than anatomical scans? Maybe we can ask Tibor, if he wants, maybe Tibor, do you want to elaborate on that?
I can invite Tibor on screen. I'm going to throw Alberto off.
I mean, in a way, it is already used for the bold scans, for example, and maybe also
Tibor is on his way.
Does anyone else have a question? How does this usually work?
Yeah, that's fine. It is sometimes people come on screen and then talk for an hour, and some other times you have a gap between the questions. But if anyone has a question, you're welcome to either come on screen or add it to the ask a question functionality. There's already been quite a number of discussion points on the one that Tibor asked. It seems like Tibor is having some trouble. Ah, there he is.
Hi, Tibor.
Hey, hello. Hi.
Hey.
Good afternoon or good morning to you.
Yeah.
So yes, the idea is that So first of, in the beginning, we had a long discussions about the grouping scans, and in the beginning, I was also questioning why do we need the group scans at all, because in some cases you can just use entities for that. And I think we had a discussion on the pull request as well, or maybe that if you really want to force it, sometimes you can force certain sequences with suffixes for sure, or sorry, with entities for sure, but there are cases they're just too cumbersome. And I think the real question is, and I think the real difference between people who argue one or the other is that they come from different perspectives. Because if you come from the data producer perspective, then using entities might be an easy way to go, because you can, this is a scan and use different entities to differentiate different scans, and that's all right. But I think one of the main motivation for the grouping suffixes, and that was kind of my impression from the discussion, is that it really helps for the developers, the data users and the developers of the toolboxes processing these images, because it makes it much easier to, first of all, check if you have all the dependencies for your toolbox, if all the images are there, and also just easier just to grab the actual images for your toolbox. And then I thought, well, it's quite a very, very great thing to have, and maybe we could just also use it not just part of the ANET modality, as also pointed or suggested by the poster, but also like a general concept, modality independent concept in the BIDS, and probably maybe just not only for MRI, but maybe for other other acquisitions could be useful.
But even from a user's perspective, if there's a data standard to collect certain type of data, let's say for quantitative MRI, I really would like to be able to collect all those images for one subject and still be easily delineate them from each other, right? So the specification should serve this purpose. So if we avoid these grouping suffixes and try to use entities along to achieve that, I can easily imagine lots of different quantitative MRI methods are having the exact same name with entities and a common suffix like GRE, let's say. So you can easily confuse the images that are intended for T1 mapping from those intended for B1 plus mapping. And to understand, you need to go and check other parameters in the JSON file that may not exist because they may be some really specific entities. So this is, I think, one of the advantages of the grouping suffixes. So they make it easy to distinguish these images from each other that you cannot easily do solely with entities. I guess it worked for both parties.
Now, right? So that's great. A bigger question is if this is useful for other modalities as well. So I guess yes. I guess to some extent it's already being used to do that.
Yeah, for
in a way, multiple runs of a functional scan in DTI with the different directions. So I guess the question is whether we should move some piece of text to the general principles of BIDS and elaborate on that. Is that what you mean, Tibor?
Yes, and also, I mean, it may be open a can of worms as well, because just as you also discussed, the multi-echo API might fall into that category, and it means that the bold suffix at the moment is not defined as a grouping suffix. So just based on the specs, it might be, I don't know, we may just need to make it clear that, or that's also a question, we want to give the bold like a modality suffix or a conventional contrast-specific suffix, or do you also want to add it or move it to the grouping suffix? And of course, in theory, a group can also just constitute just one item. Again, if we say the bold is then a grouping suffix, maybe that could be also added. And for the DTI, I didn't remember the different directions, because different directions in diffusions are just coded in the BVOL, BVEX files, and the DTI acquisition is just one 4-dimensional image. What I rather meant is that, but again, it's another discussion, is some sequences might come out with some pre-processed maps, or again, I can imagine some more exotic diffusion, tensor or Kurzweil imaging sequences, which might come up some images with some very preliminary processing from the scanner. And again, if we accept the definition that the raw images what comes out of the scanner without any offline toolboxes, in theory, they should also go into the BIDS core. And in this case, they might be also use the grouping, suffix or grouping concept. And again, if you think about the field, I probably the field maps was not a good idea. I was just thinking about it. But when there is a field map, for example, if you think about the conventional field map, the Siemens field map at least, then you have a magnitude image and phase difference image. Again, at the moment, we just have two different suffixes, but again, we can think about it, grouping them together.
Yeah, three even. There's magnitude 1 and 2, I think.
Exactly, but I think that can wait independent from this.
Yeah, so I think concretely we can do two things with this. So first of all, this should maybe, for BIDS 2.0, it's good to think about these things. Like, can harmonize this idea. And point 2 is maybe we can look into the PR. There's a way to move things towards a more general section. Although I don't know how useful that is in the whole BIDS timeline. I don't even know when BIDS 2.0 is supposed to come out. Or, yeah.
I was also a little bit worried about it, to be honest.
If we're going to do that in half a year, then it's not much use maybe to rewrite the general principles.
Yes. Yeah.
I don't know. Maybe someone else has thought about it. What do you think, Agah?
I mean, when we are creating a description for these grouping suffixes, we will probably definitely start at only from the anatomical imaging data, but then you notice that, yes, when BOLD is trying to apply a similar concept, the BOLD suffix may be also called as a grouping suffix, which may require rendering these grouping suffixes as a principle. But on the other hand, it may conflict with the existing descriptions. So, yeah, it's a bit complicated. Yeah.
Well, I don't think that if you just change the definition or the position of the BOLD, I mean, we may not necessarily want to do it, but even if you just move to redefine the BOLD suffix, it doesn't change the data itself or any data sets. It shouldn't cause any backward compatibility issue, because the data sets themselves shouldn't change.
Yeah. Yeah, and I, approaching from multi-echo fMRI angle, I clearly see that why the use of entities makes it clear that like the entity should be enough to differentiate those images. But for quantitative MRI, the same logic cannot easily apply.
Does anyone want to comment on Taylor's comment?
Mm-hmm.
Okay.
Yes, so he's absolutely right. So, and that's what he said. So even if you consider even one scan as a group, then in theory any suffix can be a grouping suffix. But I think, and that was again part of discussion on the PR. I think that these grouping suffixes are rather saying something about the purpose of the acquisition, and a bit less about, for example, the contrast. So like if you think about the convention, most of the conventional suffixes, I think at the moment it's called conventional suffix in the specs. They are the T2 star, T2 whatever. So it is more like things say something about what is the actual image. And I think again the field map is a bit different, because the field map suffixes, they again say something about the purpose of the acquisition. And that's why they might be better rendered as grouping suffixes.
Yeah. So right now in the draft, in the proposed draft, task imaging data is basically completely separate from anatomical data. So within the domain of functional imaging, there's no concept of grouped scans or even quantitative scans. I don't know if right now that's also a problem. I guess there are quantitative functional images actually.
So I think that the first question is if the community is happy to accept the grouping suffix at any level. And if they are, and we can keep it in the PR, moving it from anatomy to the common concept doesn't really hurt or change anything, because obviously if there's a concept, it doesn't have to be applied, but we will apply there as well. Just that I thought the grouping suffix is something which is more like a concept and not just for anatomical. We can just leave this question open for further discussions.
And then probably in an appendix, we can also explain which grouping suffixes were born grouping suffixes and which ones become grouping suffixes after, depending on how you collect your data. Because, for example, if I have a T1 weighted image and when I have run 1 and run 2, the T1 weighted image doesn't become a grouping suffix, right? So we should make that distinction clear.
Absolutely.
And then I guess we can generalize this concept easily.
Some motivation of this question was rather than that I thought maybe other groups or other proposals are also thinking about some issues which could be solved with the grouping suffixes, and if we put it into the general concept, then it would make them better visible. Because again, when we are developing the Web 01, we doesn't necessarily have any other modalities or any other groups or BEPs in our mind, and I just want to avoid the reinventing the wheel all the time.
Okay, well, let's maybe have a look at the PR again and see if it's easy to move. Is there any other issue someone wants to discuss?
There was a question by Matthew in the chat.
Maybe you can call it a day. Stefan?
Yeah, I don't know if Matthew wants to come up and discuss his question quickly as the last one, or otherwise you discuss it on screen. So it's in the chat. It says, "What's your view on the fact, even though we are standardizing?"
Yeah, I would just like to thank everyone then for the feedback of this great community and making it easier to share data and to make pipelines. That's gonna save so many hours of hard work in the future. No, I don't hear you, Stefan, but maybe someone else does.
Can anyone hear me? Hi. Oh, everyone could hear me. There was a question. Can you still hear me? Oh, can you hear me now, Gilles?
I can hear you. Yes.
Okay, great. There was a question by Matthew in the chat. I don't know if you see it. If you scroll up a bit, what's your view on the fact, even though you are standardizing dataset parameters, there will be two standards, etc., etc. Do you want to have a quick comment on that before we end?
Agah would be, since Agah is more of an MR physicist, he would be better positioned to answer that question.
Yeah, we discussed these issues with Matthew in the background quite a lot, given that we are working together. But also, I mean, even these parameter names may change from vendor to vendor, so it's a really difficult variance to unify, I believe. And one of the questions is that which one is easier, like convincing MRI physics to use the ones in BIDS format or the other way around? Well, I don't know. I guess what we can do is that we have lots of users for a specific type of data, and for these ones, we can at least try unifying these metadata values and see how it plays out. And then maybe MRI physicists see it and they become jealous and they'd like to use it as well. And then that would be the best case scenario. Otherwise, I don't think that there's an easy way to convince them. But yeah, to somehow, yeah, that's convincing the MRI physicist is not the plan. What do you think, Gilles?
Well, I mean, there is no alternative BIDS for this particular kind of data, right? So of course there's DICOM, and there's a certain kind of words people use, like MR physicists usually mean something else when they say repetition time compared to the FSL users. But I don't think there's another file standard that really, you know, is the cool thing about BIDS is that it's so exact that you can easily make pipelines where it's just plug and play and it works. I don't know of any effort like that for these kind of data. But maybe there's something specific you're talking about, Matthew. I don't know.
Not saying this because he's my advisor. He said that just awareness of the discrepancy will go a long way toward uniting the two communities. And I guess, yeah, that's the most unifying response. Yeah. We have one more question on the question section.
No, it was just the same question.
Yeah, copy paste different. Okay.
I think, so you've got 5 minutes left. I don't know how you want to use that. Wisely.
I already tried to end this by saying I'm really happy with this effort. I think it was a lot of work. And it shows that it's not easy to make something like this without a centralized entity that sort of says this is what you're gonna do, right? You have to do it together as a community, and that's not easy, but it's also very rewarding. And there's something beautiful, and there's no project like this for me where I interact with people with so many different backgrounds and also from very different places. And that has been very exciting, and I think it shows that this is a great example of open science at its best. That's the best I can do, Stefan.
That's definitely good enough. For me, at least.
Good.
Agah, do you want to say something to round off?
To wrap up, nothing much. I think it went really well, and thank you everyone for raising these concerns, and we are happy to move on with these discussions on the pull request, and we are doing our best to discuss all the issues and come up with something that works for everyone.
Cool. Well, thanks a lot for joining, and thanks for suggesting the session.
Thank you so much, Stefan.
Thanks everyone for listening.